Welcome to E542 Lab 6 by Professor Young Cho. This is Akshay and my teammate Praveen. We're going to walk you through the lab quickly. So let's see the problem statement first. So the task is to implement a machine learning code which would give us the F score using the training and testing data. So the task is to differentiate between the forged and the genuine banknote. So we implement this task using two techniques, which is like AWS SageMaker, and the second is implementing the machine learning task on Amazon's deep learning AMI. So we make use of the Bayesian classifier to get the F score, and then we finally plot our results, and we are able to differentiate between the forged and the genuine banknote. So let's go through the first implementation, which is using the AWS SageMaker. So as you can see in the slide, we have opened a notebook instance, and then we have also opened the S3 bucket in which we load the Python file and then the text file which has been provided to us, which contains the data. I'll quickly show you the implementation of the AWS SageMaker. So here, as you can see, we have created a notebook instance named Lab6, and it's already in service. Since it takes a little bit of time to start, we have skipped that part, and then now the status shows in service. And I'll show you the S3 bucket where we have created the .txt file which has been provided to us, and this is our Python code which implements the Bayesian classifier. Yeah, so this S3 bucket files have been transferred to the notebook instance, and this makes use of those files to run the code. I'll show you the quick implementation of our code. So as you can see, we've used the logistic regression technique also to compare the results with our main classifier, which is the Bayesian classifier. And then when we run the code, yeah, so we have the run option. We do run all code, and then as you can see in the console, we have gained all the plots, and then we have two techniques result, which is the Bayesian classifier, which gives us a F score of 0.84. The test accuracy is 84.3, and as you can see in logistic regression, the test accuracy is 71.4. And so we can conclude that the Bayesian classifier is better. The reasons I've mentioned in the PPT, as you can see here. So we make use of the Bayesian classifier uh, instead of the logistic regression because it requires less training data than the logistic regression. Since our data is also limited here, using Bayesian classifier is a good choice. And then there are more advantages of Bayesian classifier, such as the RAM memory footprint required is like modest level, and it doesn't use the CPU much. And it also, yeah, the main advantage of Bayesian classifier is that it scales linearly with the number of features and number of data points, and it also handles missing features by retraining the data and predicting the values. So as shown here, we have plotted the results which I showed in the previous implementation. As you can see in the base classifier, the F score, as I said, is 0.84 as compared to the F score using logistic regression, which is 0.69, which proves that our Bayesian classifier works better than the logistic regression. This was the AWS SageMaker implementation. So we implemented our machine learning task on the SageMaker platform, but we can do the same on deep learning AMI, which is our second part of the lab. And I would like Praveen to, yeah, implement that.
So, as we observed, Akshay has explained that the same thing can be done over the deep learning AMI. So, what machine we have actually used here is a 64-bit Ubuntu machine, which has all the pre-installed libraries. So, we don't have to actually go through the pain of installing all the libraries as we had in the SageMaker. So, as you can see that the instance is up and running. I don't want you to run over the actual way of how we did it. So, I've already have the up and running machine. So, next I'm basically going to show you how we went on to SSH into that particular instance and then run the code in the Jupyter machine. So this is the command through which, so I'm basically SSHing into my DNS public, this is my public DNS IP, and I'm basically going to SSH into that. So as you can see, my machine is actually active, and all those libraries which are required for running my code are already up and running here. So what I'm actually going to do right now is run my notebook. Right, so Jupyter lab. So as you can see, my notebook is up and running, and I've actually got a link over which I can go and show you my implementation of my code. So the lab is instantiating. Right. So we already have the code for Lab6, and as well as the data which we'll be using to run the following code. So here is the implementation of a Bayesian code. It's a rough estimation of how we went about doing it. So I'm just going to run the following code and show you the output. I'm just going to open a console for that. Right. Takes some time. Right. Yeah. So as you can see, the accuracy is about 85%, and all the figures are plotted below. So as we can see, we actually implemented it over the SageMaker and the deep learning AMI, and the accuracy we got was about the same. So that was the objective of our lab, and thank you for being with us. The results are also been displayed in the report here. So those are almost the same what have we got by doing the physical implementation of this. Thank you for being with us. See you in next lab.